Hello. This one we're going to talk about the conservation of energy. Now, conservation of energy has a formal definition. I'm going to give you an example that will best relate the ideas behind conservation of energy. Now, conservation of energy states this: if all external forces are ignored, the total mechanical energy, that is the sum of your potential and kinetic energies of a system, remains constant. Now, you're probably thinking, what does that mean? That means if we disregard all external forces, usually frictional forces of wind resistance, friction, anything like that, the sum of the potential and kinetic energy throughout the motion of an object remains the same. Say we take a pendulum, and say right now this pendulum is at rest. This is the low point before we move it. If we take the pendulum bob and we pull it up here to this height, and we've done work. We've applied a force, we've moved an object some distance. So we've done work. We've done work, we've added energy to that pendulum. Specifically, since we're holding it here, we've elevated it, that would be gravitational potential energy. And say at that point, the pendulum bob has 10 joules of potential energy. As we're holding it here, it's not in motion, so it would have no kinetic energy. What conservation of energy is saying is, once we release that, the sum of these two potential and kinetic energies will remain the same throughout the motion of the pendulum if we ignore external forces, that being wind resistance, friction in the joint up here of the pendulum itself, and so forth. So say we release it, and now the pendulum is at a point right here where we have a potential energy of 7 joules. If they add up to the same thing throughout the motion, 10 plus 0 is 10. That means these two have to add up to 10. If we have 7 joules of potential, that means we have 3 joules of kinetic energy. So we're going from all potential and 0 kinetic. There's a gradual shift. Eventually we get to the low point of the swing where it's all kinetic. At the low point, or the equilibrium position, we're going to have 10 joules of kinetic energy and 0 joules of potential. So we're going from 10 joules of potential to 0 kinetic at the high point of the swing. Eventually, we have 10 joules of kinetic and 0 joules of potential at the low point. And it's a gradual change back and forth. But all of this time, those two will always add up to the same amount. In this case, 10 joules. As it comes back up to the other side here, at the high point, again, ignoring friction, ignoring wind resistance, you would have a potential energy of 10 joules and a kinetic energy of 0 joules. Now, that's all fine and dandy. That's the idea behind it, but you also have to do some calculations with it. Say, for instance, I gave you the mass of the pendulum bob and all the wire and so forth is 5 kilograms. I want to know how fast is the pendulum bob moving at the low point of the swing. So how fast is the pendulum bob moving at the low point? All right, well, what do we know? We know mass is 5 kilograms. The low point, we know we have the kinetic energy, 10 joules. We want to know how fast it's moving, that's velocity. Right off the bat, kinetic energy, the formula is 1/2 mv squared. Instead of rearranging for v first, what I'd rather you do is plug in the values you know, simplify it, and then solve for v. So in this case, our kinetic energy is 10 joules. That equals 1/2 the mass, which is 5 kilograms, times the velocity squared. I'll simplify. Half of 5 is 2.5. So 2.5 times v squared equals 10. Divide both sides by 2.5. Those cancel out. You got v squared. 10 divided by 2.5 is simply 4. That gives you v squared. We want to square root that. Square root of 4 is 2. And the unit would be meters per second. So, the velocity of the pendulum bob, which is 5 kilogram pendulum bob, that has 10 joules of kinetic energy at the low point of the swing, will be traveling at 2 meters per second. So this is using the kinetic energy formula and the idea behind it, but we're looking for a different quantity. And you're going to be asked to do things like that, where you may have to use kinetic energy formula or one of the potential energy formulas, solve for a different quantity. That's fine. In my opinion, it's a lot easier to plug in the numbers you have and simplify it The rear inch is all for the rain garden. But that should do you for module 6. Good luck.